Hey guys, we are back with our last session now. We have Sam here from the IOTA Foundation team. He's a senior software engineer working with them, and he will be talking about building POCs on system on chip. So it's a new concept for me also. I'm very excited to know what exactly is what they are working on. Over to you, Sam.
Okay.
Sam, you would like to share your screen to showcase your presentation?
Yeah. I'm trying to do it. Okay.
Perfect.
Can you guys see me? My presentation? Yeah. Okay. Senior engineer from IOTA Foundation and based in Taiwan. And if you are interested about this slide, and you can scan the QR code on this slide, and you can get the slide. Yeah. So maybe I will waiting for 10 seconds for everyone to scan the slide. Okay. And in the IOTA Foundation, I'm doing the client library develop. So basically in C language. So that's why I want to talk about the client libraries on the system on chip. Yeah. So I will briefly talk about the Node and the client application. I think the the Daniel and the other speaker already talked a lot about the IOTA technology. So I just have a quick recap. Yeah. And so there were two proof of concept on the client library. One is the wallet, and the second one is the IOTA cashier. It's like a vending machine concept. And later I will introduce about the IO is a framework for embedded system developed to integrate their implementation faster. And so I'll talk about after this introduce this proof of concept and what you can do and what's the plan for the next. So basically, the IOTA node is the core of the IOTA backbone, and the node is doing storing and the broadcasting and the validating the transactions. So it stores the transaction on the computer or node devices, and then do validating. Also provide the client APIs to communicate with the clients. So we in the foundation we have some node applications. First is IRI implementation, and it is currently is kind of retired. So now we recommend the Hane node. So the second one, the third one is Conical. Conical is kind of the node they keep all the history, because the IR node and the Hane node only keep the partial transactions on the node, and it could be the data could be erased or from the node. It depends on the node configuration. So the Gossamer is another implementation, and it is still work in progress and by our research team. And it implements a prototype of the Tango without a coordinator. And the last is B. B is a frame. We design it as a framework of IOTA nodes and the clients. So it's a kind of you can imagine like a kind of library, and it can use on the nodes and client applications. And it is written in Rust language. And the client, IOTA client is basically like a IOTA network user. So it keeps a seed on the client, and the seed is for address generation, and it can send the transaction to the Tango, not the data. Sorry. And the client library, we have several language implementation like IOTA.C, Go language, and Java, JavaScript, Python, Rust. And so you can choose whatever you familiar to implement your client. Sorry. So you can see you can find a lot of documentation and terminology on our documentation website, and like how to run a node and writing a client applications. So today I will focus on the client application. So first is IOTA Wallet. It's a text-based application that can allow you to talk to the Tango network, like send transaction and query your token on a specific address. And also it can run the also get the node information, like which node you connect to, and you can see the node situation, like if node is sync or unsync, and so on. Yeah. So there is two projects on this wallet implementation. One is ESP32 wallet, and the other is CLI wallet. And the CLI one, ESP32 wallet is based on the SOC, and the CLI wallet, it can run on the POSIX platform, like Linux or FreeRTOS or your on Windows. Yeah. So this is the wallet system architecture. Basically, it is architecture on the ESP32. So you can see how you have a hardware abstraction layer, and you have a FreeRTOS kernel, and also have a network stack. So what we need is the ESP32 developed framework that provide the ESP Wi-Fi API, and also SNTP client, so we can connect to the NTP server to get the real time. Yeah, and also there is a wallet console, and it handle the user's input and display the result on the console. And also we have a IOTA command. It serve as a talk to the IOTA node like IRI or Hotnet, and currently it supports some commands like node info and client config, and also C, and you can set C on the change the C on the ESP32. Also, this account command is show your addresses and including the balance in the address. Also have a address because right now IOTA right now our network is not recommend to reuse the address because it could be expose your private key. So, but we already have research to do the work to finalize our implementation, how to fix this problem. Like we can use the address again. Yeah. Also, they have transactions like find transactions on the network, and also get the balance from a specific address. And the most important is send. It can send tokens or send the data in the transactions. And also get address. It can generate the address from the C. Yeah. And the reattach is another feature. Like sometimes the network your transaction is not unable to be confirmed as fast as you think. So you need to you can do the reattach to the Tango, and it will help you to process faster. So it kind of send a new attach a new transaction to the network, because transaction is too old to stay on the Tango too long, and unable get a confirmation, and it had a chance to pending, and cannot get a confirmation. Yeah. So I'll talk about the other projects. IOTA Cashier is like another way to pay. Like this is a vending machine in Taiwan. Like on my left side is a traditional vending machine. You can put the coins and get your drinks, and then we become to use the cards like a easy card in Taiwan is kind of a RFID card, and you don't need to have a physical contact, and you just can store your money in the easy card, and you can use it on the vending machine. And so it could be, so right now you have a IOTA network, and you can use it as a payment system. So this proof of concept is also use the ESP32, right? But ESP32 it doesn't have a LCD, so you need to wire LCD. Yeah. So this the IOTA cashier flow. Like it initialize the LCD, and then initialize Wi-Fi and find the Wi-Fi SSID and also then check the address, receiving address. It can configure to use a specific receiving address, or the address is generated from the seed. Also, you need to update the time, use the SNTP. So after setup, and he will get the balance. So play on the screen and start to do the monitoring task. So it's waiting for the payment. So let's see the demo. So this is how this IOTA cashier receive the token. And first, I can use the Trinity Wallet is installed on the cell phone and to scan the QR code, and you can get the address, and you can put how much amount you want to send to this vending machine. Yeah. So once the machine get confirmed, and once the transaction get confirmed by the Tango, and it will update to the screen and notify. So the transaction was confirmed, so it received 1K on this address. So it's kind of you pay the machine, pay the vending machine, and you got the money. And if you are a machine owner, and you can withdraw the token, also use the Trinity Wallet, and you just so you can use the Trinity Wallet to send out the token, and when the transaction get confirmed, and the vending machine also know the balance was changed, so it can update to the screen, also renew the address. So because in IOTA, if one address is used to send out the token, and we don't recommend you to send the token again on this address. But this protection is already on the Trinity Wallet, so you don't worry about it if you use the Trinity Wallet. But if you use the client library, and you might don't have this kind of protection, and you need to implement it right now. So that's the concept of the IOTA cashier. And next I will talk about the Platform.io. Platform.io is a new developed framework. Like it has 33 platforms and 21 frameworks. Also support more than 800 developers. So it's a very interesting project and it's open source. Yeah. So it's very simple. You use the client library on the platform IO. I have create a repository and there is 3 examples like Arduino ESP32. It's ESP32 use the Arduino framework, and the other is ESP IDF framework, and then we have STM32 developed board. Yeah. So you can use this example to create your application as well. So use the client library on the platform IO is very simple because it have easy to use framework. So you just only fill in the external libraries and to specific to point out what platform you want to use and your developer and your framework. Also, platform IO you can use as a plugin in the VS Code. So it's very convenient to use to combine with the VS Code, also other IDE, and it provide a lot of tasks, and you can like build a firmware and upload to the device. Also run a unit test. And this is example of the unit test, and you can see that this test is run the address generation and to generate the different address and to count the time spent. Yeah. So I want to talk about what this project can do, and you can use for learn IOTA technology from this proof of concepts, and also maybe you can host a workshop to have more people to understand this client application and also understand how the IOTA node work. And also you can put into the other platform like Stack5 or other STM controller. And also you can create your own proof of concept from these examples and to do other applications. So that's my presentation, and thank you. If you want to reach me out, and you can join our Discord, and here's my ID. Yeah.
Thank you, Stan. That was some really interesting things to learn about. There are a couple of questions that people have. So first question is, are you transmitting any data in addition to IOTA tokens in the POC? If you want, you can click on the questions yourself and also read the questions.
Okay.
It's right below the chats.
Are you transmitting any data MM strings in addition to other tokens in the proof concept? No, I haven't do the full concept on the streams or the main, and it just send the simple transactions on to the Tango, and the data is not like streams, not like IOTA stream is not continuous, but is you can design the data on the specific address, and you can query the transaction from the address and to fetch your data. Yeah.
Okay. Second question is, chip is able to communicate with the blockchain?
I don't understand what do you mean the chip? You mean the ESP32?
Okay. So Praveen, can you just give an explanation exactly what do you mean here by chip? So there's another question asking, how do you say this as a SOC, system on chip?
Let's say SoC, system on chip. Because ESP32 is not a single microcontroller, and it just is a kind of built-in Wi-Fi module, and also have it has a Wi-Fi module and also Bluetooth module and other peripherals. And usually microcontroller don't have a built-in Wi-Fi module, because the Wi-Fi is kind of big for the microcontroller. Yeah. So I call it SoC. Yeah.
All right. So in addition to this question, someone is also asking, it looks like a normal application that runs on top of POSIX platform. SOC means IOTA is implemented on the hardware level. If you scroll down, it's the second last question.
Second last question?
Yes.
Okay.
Yeah.
You say it's like a normal application that run on top of POSIX. SoC means IOTA is implemented on the hardware level. It runs on the SoC, but not integrated to the hardware. It's like it's run on the POSIX platform, not built into the hardware. Yeah. It's pure software right now. Yeah.
All right. Okay. So where we had earlier asked the question about chip is able to communicate with the blockchain, it means in the kiosk system that you showed in your presentation. How is the chip is the chip there able to communicate with the blockchain?
No, I don't know. And actually, I'm not sure if it can communicate with the blockchain, but it can communicate with the IOTA Tango. Yeah.
Okay. All right. So this is another question is, can we install IOTA node on IoT devices or sensors which are low power and low compute constrained devices whose data is sent over a low bandwidth network like cellular envoy, and recently critical flaws in embedded TCP live impacting. So basically, the person wants to know if we can install IOTA node on IoT devices or sensors with low bandwidth.
It's kind of challenging, but I'm not sure it's doable, because as a IOTA node, you need to have a fast I/O. So because when node get online and he will receive a lot of transactions, and he need to store this transaction data into database or what other storages. So I think the challenge is about the IO bound. Yeah, it could be cause the problem on the iOS. Yeah.
All right. Okay. So we have two more questions. Abhay, can you explain what do you mean here by devices? How those can be overcome? The question there. And the other one is, what's the TPS of IOTA with SOC? Transaction per second of IOTA with system of chips.
I don't have exactly number on it, but we have some IOTA node run on the Raspberry Pi. Yeah.
All right. Okay. Okay. Thank you. Any more questions? All right. This one is here. That was the part earlier question and recently critical flaws in embedded. Okay. Abhi, if it's okay, can you raise your hand and I'll bring you on screen so that you can directly ask the question, because I'm not able to follow what exactly your question is. Or can you just type it again so that we can then, it will be easier for Sam to answer the question. Perfect. Abhi, you can ask your question now.
Yeah, actually, the question was basically around, like, currently we are also working on IoT projects where we have different use cases, like tracking of the devices or door sensors, the door sensors or logistic trackers. So there, what we are using, the devices are of very low compute power and the networks which we are using, and NB-IoT, which is basically narrowband IoT, where the bandwidth is pretty less. So there, if we want to there for the secure transaction of the sensor data, if I want to use an IoT blockchain node, so will I be able to do it? And then the second part was, like, recently we in the SOC in the SOCs, they use embedded TCP/IP library. So there what we have found in our lab testing was that there is a flaw there, which has caused many effects in the devices. So how can that be overcome using a blockchain technology?
So my understanding is that you mean if the client can use on the narrowband IoT, and the answer is yes. And we have, as I know, have some community member or the company already have implement this do this proof of concept, and because right now IOTA network is built on based on the TCP/IP. So you, as long as you can send the transaction through the TCP/IP, and then you can communicate with the network. Also, usually the IoT system could be have a IoT gateway in the between the sensor device and the cloud. So in some cases you can use the client library in the IoT gateway and to collect the data or do whatever you want to do, and send the transaction by from the IoT gateway to the Tango network. Yeah.
So like currently, like for the sensor data which we are transmitting, we are using say MQTT for the payload. So if I send the payload over MQTT, and will that be able to communicate with the Tangle network?
Yeah, MQTT is has support on the Harnett node. So it's you can use the MQTT to communicate with the Harnett node, but it is not support on the II node yet. But yeah.
Okay, thank you.
All right. Okay. Thank you, Abhay. Anyone else has any other questions? Okay, we have. All right. I think so. All the questions been answered. All right. Okay. Thank you, Sam, for such a lovely session.
Thank you.
It was really nice. Thank you, everyone, for being a part of our session today and learning about IOTA. I will end this session, and we can in the social lounge. You guys can network and talk to the speakers and network with each other and understand what's happening around. Thanks a lot. If you guys want, do join our social media forums, and you will get to know more about our activities and the initiatives that we keep doing, and keep yourself updated with what's happening in the ecosystem, and join our discussions. Thanks a lot, and we will be mailing you all the PPTs and the recordings for your benefit. Thank you, guys.